Okay, so I realize that some students may be confused by what's called a reference angle. Certainly when we did this section of the notes, we talked about reference triangles. And at Essex, we only really talk about two reference triangles. That's the 45, 45, 90 and the 30, 60, 90. It goes on to say, something about a reference angle. And certainly we're hoping you guys like actually read what we give you, because I realize sometimes when I'm talking to you, it may go, I always say in one ear out the other, but it says, let me just read this to you. It says, once the above triangles are formed, you should be able to use these triangles to evaluate the 16 points. And we did that in the lecture. We actually evaluated all 16 points using, basic triangles and looking at really simple points. And those points would be the ones along the X and Y axis or the abscissant ordinate. So my claim is those 16 points, some teachers say, oh, you should memorize those 16 points. I think you should understand them. However, I want to point out that although we only talk about the 30, 60, 90 and the 45, 45, 90, and this diagram over here, there's actually an infinite number of reference triangles. There's an infinite number of them, right? You have to understand there's a large variety of triangles that you could put down. Now, someone says, why do you just talk about these two over here? The 45, 45, 90 and the 30, 60, 90. Well, because they're easy. That's number one reason. But the bottom line is you should still be able to think about other triangles, ones that don't have angles that are 30, 60, or 45. All right. So what I want to do is I'm going to go to the whiteboard and I want to talk about the reference angle for the triangle. All right. Now the reference angles we've done a reference of 30, a 60, and a 45. Of course, we can talk in radians as well. So I'm going to switch over to the whiteboard. Give me 1 second to do so. Whoops, I don't think I switched over. Sorry about that. All right, now I'm on the whiteboard. So we're back at the diagram. And I just want to make sure you understand there's angles down here with degree measure and with radian measure. So let me just go through that with you. So over here, if the terminal side's along the x-axis, like this over here, the angle could be 0 degrees or some multiple of 360 degrees. Because why is that? Once around, twice around, so forth and so on. You could also go in the other direction, of course. But just to keep it positive for a second, right? And as you certainly move around, if this is 0 degrees, 30 degrees, this would be 45 degrees, 60, 90, 120, 150, so forth and so on. I think you should have a feel for degrees and revolutions. All right, you should have a feel for that. Now the radian measure, a little more difficult, but the bottom line is it shouldn't be terribly difficult to you. For example, if I were terminal side over here, it would be 0. And as we start to move it around them, you should notice an equivalence between these numbers over here. For example, 30 degrees is equivalent to pi over 6, 45 degrees is equivalent to pi over 4, 6 degrees is equivalent to pi over 3, 90 degrees equivalent to pi over 2. If you're doing revolutions though, no revolution. If you look at this one over here, this would actually be 1/12 of a revolution, all right? 1/12 of a revolution, all right? It may take time to think about that, but you should think about things like that. Again, I'm not going to say you're going to be terribly fast at it, but you should think about that. Now, what would this one over here be? It would be 1/8 of a revolution. What would this one over here be? 1/6 of a revolution. What's this one over here? 1/4 of a revolution, all right? Now, I'm going to get to the reference angle now. I'm going to write it down for you. The reference angle. And so when I was doing the problems, I would say just theta sub r, and then I would talk about the reference triangle. And the reference triangle had an acute angle. So theta sub r, all right, is going to be an acute angle. It's acute. All right. And again, we're talking about triangles now. So I'm going to say between 0 degrees and 90 degrees, or if you were in, revolutions, between 0 revolutions and 1/4 revolutions. If you were if you were dealing with the radian measure, you would say between 0 and pi over 2 for the acute angle. All right. Now, what I'm going to claim over here is that it's going to be an acute angle, and it's going to be formed with respect to the abscissa. So it's an acute angle. With respect to the x-axis. All right, so for example, if I were to get a terminal side, I'll draw a picture of a terminal side down for you, like this. This is the angle. What's the angle? The angle theta is 150 degrees, all right? What's the reference angle though? It's the acute angle formed with the x-axis. What is that acute angle? Well, look at it. 150 to 180, it's got to be 30 degrees. All right, let's do another one. Let me just go backwards. And again, we're hoping this makes sense to you as far as words go. We're talking about reference angles. They're acute. They're formed with the x-axis. We look at the terminal side and we say, how much further do we have to go to get to that x-axis to get there? So let me get my eraser out. I'm going to erase this business over here. We're done with it. Erase this over here. And we'll do another one. Right? What's another one? Well, I'll put it over here. This is the angle. And what's the angle? I'll write it down for you. The angle is going to be 240 degrees. Now, someone says, what's the reference angle? I'll put this one in blue this time. The reference is an acute angle formed with the x-axis. It's really a simple arithmetic problem. What is it going to be? We're just looking at the picture. And again, you should be very familiar with degrees. It's going to be what? Well, 180 to 240 is 60 degrees times. All right. Let me get my eraser out. I'll erase this one. Again, these videos will be published at the end of the week, and you can watch them if you want. I'm hoping we're going slow enough where you can understand what's being said, though. All right. Let me do one more. And let me do this one over here. And someone says, what's that angle over there? Well, I hope you realize I'm trying to do really simple reference angles. Now, before I get to reference angle, what's the angle? Well, I'm looking at it, and it looks like some multiple of 45, like 1, 2, 3, 4, 5, 6, 7. So I'm going to say 7 times 45, right? And what's that going to be? 315 degrees. All right, 315 degrees. Now, someone says, what's the reference? Let me repeat this. It's an acute angle formed with the x-axis. This is the only acute angle we could come up with. And what's that going to be? Well, if you're at 315, you want to get the 360. That's one way around, right? That would be a 45-degree reference. Okay, let me erase. We did some sums. We've been doing these in class as well. Hoping that's not too confusing to you. I'll repeat this. At Essex, we deal with basically two simple triangles. The 30, 60, 90 triangle, that's a right triangle, by the way, and the 45, 45, 90 triangle. Then we're talking degrees, right? But there's an infinite number of them. So for example, if I said the angle, I'm going to write this down now for you. If I said the theta was 211 degrees, and then someone said, what's the reference? Well, I hope you know by looking at it, it's not related to ones we've been talking about, like the 30, the 60, or the 45. But let me kind of ballpark it for you. And when I ballpark something, I'm not saying I'm doing a terribly good job, but 211 degrees, I got to start here at 0, 90, 180, right? And then I got to go more to get to 211, right? Now where's 211? It's a little bit past 210. Then someone says, I wonder what the reference is. Well, if you thought about it, and we would like you to think about it, what's that going to be? It's going to be 211 minus 180 degrees. And what's that going to give you? Well, I hope you can do the arithmetic. I hate to see you go on a calculator, but I'll be honest with you, I wouldn't know if you were going to a calculator. I just wouldn't see it. Again, you should learn arithmetic. What's that going to be? 31 degrees, right? That should not present too much trouble for you. Let's take another example. This is one example. Let's take another example. Let me put down, I don't know, theta equals 372 degrees, right? The question is, what's the reference triangle? I'm sorry, angle. We're not going to draw the triangle in. So let's just like talk through it. I mean, what else could you do? I mean, you're here and you're rotating around, right? How much rotating? 372 degrees. So you're at 360. Now you have to go more. How much more? 12 degrees more. So what's the angle going to be? That reference angle is going to be 12 degrees now. Again, the reference is formed with respect to the x-axis. So that's going to be 12 degrees. Let me write that down for you. Okay, that's a degree. Let's go to radian. That can cause some trouble for some students because thinking through it, they may have to go back to the degree measure to think about it. I'm going to start to erase what I just did, and we're going to start to talk radian now. All right, let me erase. Oops, I got my eraser out. Before I do that, though, I'm going to write down what the radian measures are. 0. All right. Now, someone can say, what's the next one you're going to go to? Well, I really want to keep it really simple, and I'm hoping you want to keep things simple too. And the reason for keeping things simple is that I don't want to get so complicated that we're starting to think about, I don't know what these numbers mean anymore. But for a lot of students, the symbol pi is almost like the magic symbol. All right. But I'm hoping you have some idea that pi is a number. All right. And what's the number going to be for pi? So pi as a number is about 3.14. All right. It's about. I'm not saying it is that number. I'm saying it's about. So if I came over here, I'm going to say as an angle, this is 3.14. About. I'm not saying exactly right, but I need a feel for it. All right. Now, someone can say, are you going to do other ones? Of course I am. And the reason to do other ones, it would be nice to know what the other ones are. Right? So what are the other ones you're talking about? Well, it sure would be nice to know what pi over 2 is. And this is going to be approximately 1.57. By the way, when I put a dot above an equal sign, I'm basically saying use a calculator to get pi over 2, about 1.57. Let me do 3 pi over 2 now. Whoops. And what are you going to get? About 4.71. And this is 3 pi over 2. Okay, if you get back to 0, it's also coterminal with 2 pi. And you could do this all day long. And you might have to do it all day long. But I'm going to say about 6.28 is approximately 2 pi. All right, let's talk about reference angles now. All right, you can do this for revolutions as well, but I'm going to just stick to degrees and the radian measure at this point. So let's say they told you that the angle was equal to, I don't know, 5. Then they said, what's the reference angle? I know it's difficult. We're trying to get you to think a little bit, though. So what do you have to do? You have to rotate, and that number 5 is a number. It doesn't have degrees on it. It doesn't have to have revolutions, right? Like if it was revolutions, I go around 5 times. It does that. It was 5 degrees of a really small angle, but they said 5. Now, what does that mean? It's a unitless number. So I want to claim if you said 5, I hope you agree that 5 is between 4.71 and this number over here, which is 2 pi. So what I'm going to do is say it's over here somewhere. What's the reference going to be? It's formed with the x-axis. So what's it going to be? Well, the exact value is going to be 2 pi, right? That's all the way around. And then I back off. I'm going to take away 5 from that. All right. And that would be the acute angle there. Let's do another one. Let's say I said, this is the first example. Let's do a second example. Let's say I said theta was 4. Right? 4 units. How could I get the reference? Well, let's look at our picture. All right, just look at it. Where's 4? I hope you realize that 4 is between 3.14 and 4.71. It's over here somewhere. And what do I want? I want the acute angle formed at the x-axis. So what's the answer going to be? 4 minus pi. Again, for some students, that takes a considerable effort to do. You might make mistakes doing it, but you need to start to think. You need to start to try. Trying takes effort. Effort takes time, and you want to be able to do that. I'm going to go to revolutions now. All right, I'm going to get my eraser out. Whoops. I'm just going to be a short presentation, just to review, because I realize some students last week might have been confused by the term reference. Oh, you know what? I just erased my picture. I don't want to do that. Go backwards. Maybe I can't go backwards. I got a new picture. Let me erase the whole thing then. Sorry about that. I'll get a new picture. Don't worry. Maybe it's time for a new picture anyway. All right, let me just get the new picture here. And let me blow this thing up. Pull a picture off from this thing here. And let me pull it. And push this over here, blow it up a little bit. All right, let's take a look. Okay, let's say I said the angle theta was equal to 1.1 revolutions. Then someone said, what's the reference angle? Well, let's talk about it. What do you have to do? You have to go around 1. Well, you know, maybe I should write this down for you. This is 0 revs, or 1 rev. This here is 1/4 of a rev. This over here is 1/2 of a rev. This over here is 3/4 of a rev. All right. Now, if I look to a 1/4 rev, I could also say it's 1 1/4 revs. Coterminal. So where's 1.1? It's in the first quadrant, right? So you run around once, and then you had to go 0.1 more. So the reference is going to be 0.1 revs. All right, let's take another example. Let's say I put down, this is one example here. Let's say I said theta was equal to 0.57 revs. What's the reference angle going to be? Well, think about it. What are you doing over here? You're rotating. Now, what are you rotating? 0.57. So what are you doing? You're here. That's 0.25. That's 0.5. That's 0.75. Where's 0.57? Over here somewhere. So what's my reference going to be? Well, you go 0.5, you have to go 0.07 more. Put this over here. Again, this may require thinking. You may have to think. Thank you.